In this video, we're going to look at an interesting integral and how to solve it using integration by parts, but it's a really particular kind of method for this question. So the integral we want to find is e to the x sine x, obviously with respect to x. And thinking about integration by parts, well, let's write down our rule that we know first. So we know the integral of u v dash, as in dv by dx, with respect to x, is equal to uv minus the integral of v u dash du by dx with respect to x. And of course, integration by parts only works when u and v are both functions of x. So it's satisfied for this question. We can choose e to the x and sine x to be our u and our v. Let's do exactly that then. So u is going to be e to the x, and that means v dash, or dv by dx, has to be sine x. While continuing with integration by parts then, that means u dash, or the derivative of u with respect to x, well, that's also going to be e to the x. That's the cool thing about e. When you differentiate it, it doesn't change. And here, if we knew v dash, or dv dx, was sine x, we would want to integrate that to get to v. So when you integrate sine x, we get minus cosine x. Now let's put these into our formula then for integration by parts. So the integral of this thing, and for this method, we should call this integral I. So let's write here, this integral is called I. So I equals uv, so that's going to be e to the x times minus cos x. So that gives us minus e to the x cos x minus the integral of v du dx. So minus the integral of minus e to the x cos x dx. Okay, well, first thing we can do here, we can actually make this look a bit nicer, because minus a negative in the integral, in that integrand, we can get rid of it and just make this a plus. Normally with integration by parts though, this is now something that we can integrate, and unfortunately here it's not again. And the reason for that is because see, sine and cosine are just going to go round in circles in terms of differentiating and integrating them, and e to the x is not going to budge. What we need to do here though is have faith in this method. We need to repeat what we've just done before and see what happens. So if we now apply integration by parts for a second time on this integral, a key tip here as well is we need to stick with the same thing as u and the same thing as v as before. So our u is e to the x, and our v dash is cos x, or the derivative of v with respect to x. That means therefore that our u dash is e to the x, and our v will be sine x. We integrate v dash to get to v. So this integral here then, let's write what we've got for I equals minus e to the x cosine x plus this integral here. And by applying integration by parts again, we can see we've got uv, so we've got e to the x sine x minus the integral of v du dx. That comes out of this formula. So v du dx is going to be e to the x sine x dx. Closing up our square brackets. Well, this is where we can notice something really interesting. If I change colour, because this part here, this looks like our original integral, the integral of e to the x sine x. And you see that's exactly what we had up here. That is what we labelled as I earlier, our u dv dx. So actually this thing here is just I. This is really interesting for us because if we write this out in full now, what we have got is I equals minus e to the x cos x plus e to the x sine x minus I. We've got a minus sign in front, which is very important for us. Well, I is our original integral, so let's try and find I. If we just solve this thing, we can move this I over to the other side, and that means we've got 2I over here. So 2I equals, let's take out a factor of e to the x as well, equals e to the x, and we've got cos x plus sine x. And if that's 2I, we just want to divide by 2 to find I. So I equals e to the x over 2 brackets cos x plus sine x. I haven't included a plus c. If you really wanted one, you could in there. But our original integral can be evaluated as e to the x over 2 cos x plus sine x. That is how you do that sort of problem. Most important part is integration by parts twice. Stick with the same u as you did the first time, and that will give you the result you want.